Hey Mayport Sharks, it's Miss Slater going over scientific notation and how to write very large numbers in scientific notation form. So our I can statement is I can use scientific notation to describe a very large or very small quantities and then compare those quantities. And today we're going to look at what does $1 trillion look like? Think about that. $1 trillion. How many digits are in $1 trillion, including the pennies and dimes decimals? If you could stack $1 trillion, $1 bills, if you could stack 1 trillion $1 bills, the stack would be 68,000 miles tall. Whoa! That kind of just explains how many decimals are in $1 trillion. If you had $1 bills, that equals to $1 trillion. The stack would be 68,000 miles tall. This is more than 1/4 the distance to the moon. So if you can imagine, this is a very large number. Oftentimes this number is larger than what a calculator would compute. You can't put $1 trillion into a calculator. So how would bankers even be able to calculate that much money? So we're going to take the standard form, $1 trillion, and we're going to rewrite it in scientific notation so that it's something that we can comprehend in calculations. So because $1 trillion has all of these zeros in its decimals, in its digits, you have 3, 6, 9, 12 digits, 12 decimals. We can rewrite $1 trillion using this scientific notation, where we have 1 times 10 to the power of 12. So that is the purpose of scientific notation, taking very large or very small numbers and using the power of 10 to rewrite it in a multiplication problem so that we can understand it. So let's take a look at the number 68,000. If we wanted to write 68,000 miles into scientific notation, we need to move the decimal point to the left so that we can get a number that is a single whole digit number in between the numbers 1 and 10. So that number will always be 1 point something or 9 point something or something in between. We cannot have a 0 as the first digit because that is not a whole number, and we cannot have 10. 10 is a double digit number. So we need to move this decimal so that it becomes a single whole digit number, which means the decimal moves 4 places to the left. So 68,000 has a decimal behind the 0, and it is a large number. In order to move it to a single digit number so that the decimal falls between the 6 and the 8, we have to move it 4 places to the left. After that, we can remove any extra zeros because that is not holding the place value anymore for scientific notation. If it is a different number like 1, 2, 3, 4, 5, 6, 7, 8, or 9, you still need that number in the decimal places. If it's 0, anything after those numbers 1 through 9, then you can drop the 0 off. So after we remove the zeros, we see that we have the number 6.8. That is a single digit whole number with a decimal and then 8 in the decimal place. So if we were able to take 68,000 into scientific notation, we would have 6.8, that is the coefficient, remember always in between 1 and 10, times 10 to the 4th power because we had to move that decimal 4 times. And because we're going from a scientific notation to a large number, the exponent is always positive. So when you write a number into scientific notation, the value does not change. You're just writing it in a different expression. If we wanted to write, oh, what's this number? 1 billion. 1 billion has 3, 6, 9 zeros. So we're taking that decimal that is behind this the 0 right here. We have to move it so it is now behind the 1. Then we have one single whole number times 10. We said we had 3, 6, 9 times 10 to the 9th power. I'm moving the decimal 9 times. And that's something that you can kind of memorize, is that anything to the billionth power is going to have 9 zeros behind the decimal. Anything to the millionth power is going to have 6 zeros behind the decimal. Anything to the thousandth place will have 3 zeros behind the decimal. So these exponents 3, 6, 9 are something that you're going to get familiar with. And this is important to know when you are writing a large number in decimal scientific notation form. Taking a large number, multiplying it by a number between 1 and 10, a single whole digit number in between 1 and 10, and multiplying that by the 10 to the power of how many digits are in the standard number. I hope that makes sense. Let's practice.